except for the last two groups where it will be groups of 2. Okay, so let me quickly upload the problem statement in the chat box, and I will also share with you. Okay, so absorption column design is the first problem that we are going to work on, and this is the problem statement. I hope it is visible to everyone. Professor Basu, can you hear me?
Yes, yes. Yeah.
Good.
Actually, it was not muted. It was.
I am getting some bad network notifications. I was wondering.
Okay.
So I hope the screen is visible to all of you. I will just try to explain the problem statement. It is a mixture of air and sulfur dioxide, which we are planning to scrub it with water. So since in this water sulfur dioxide will try to dissolve, and the idea is to remove sulfur dioxide by this absorption or scrubbing operation, right? So ultimately we need to treat a certain amount of this, sulfur dioxide contaminated air, right, in this absorption tower, and all the necessary conditions and other parameters are mentioned already in the problem statement. The operation is at 30 degrees. We can safely assume that there is no change in the temperature during the operation. It is at atmospheric pressure, and the absorption column operates mostly in the counter current configuration, right? So the values for the different parameters, for example, the mass fraction of the SO2, the dry air, right, the exit concentration of the SO2, the capacity of the tower, that how much gas or how much contaminated gas it should be able to withhold, are all different. These values are different for different groups, right? So let me just go towards the bottom of this page, and you will see that these quantities A, B, C, and D are different for different groups, just to ensure that no two groups will have the same set of parameters, right? So all of you will be having your unique answers, right? But it will not be the same answer with other groups. What should be the tower specifications? For example, tray tower or spray or pack tower, etc. It's all up to you to decide. I mean, you are the designer, and you have already studied about the absorption tower in your MTP1, so you know all these things. Okay, so the first step would be, all of you, that you just quickly revise your notes or your lecture notes, go through those videos or your textbooks, and just brush up on this absorption column design, and then slowly start working on this problem. So the modalities of this class, what we will do is that we will have one-to-one interaction with all the groups. May not be every day, but at least we will ensure that we have sufficient interaction with most all of the groups, and based on your interaction there will be some marking that we will be recording, okay, in every day's class. We will be also there will be also one report that you need to submit after each problem, right? So absorption column design is one problem. The next problem will be on distillation tower, and that is actually a big problem. We need to do a lot of calculations, and after that, if time permits, then we can go for another system, right? So for each of these problems you need to submit a report, one report in each group, and every day or like every week in the regular class we will have interactions with all the groups or some of the groups, right? And to know about your progress, to get some clarifications or information, so that we are convinced that you are actually participating and making progress with your work. Also, this interaction session is quite helpful for the lively discussion about different concepts or clarifications that you need while solving the problem. So as this is the first class, so it will not be long, but just a quick like quick review of the absorption concepts. Can any one of you tell me like what would be the first step in approaching this problem? Just the first step, no need of any calculation, but what do you want to do first to begin in this problem? Anyone? Or can I ask everyone to write in the chat? What would be the first step that you will be doing? Everyone, please. There is some data related to the partial pressure of sulfur dioxide, right? Density of the solution, right? Concentration of the sulfur dioxide, in water. So what you will do with these data? What would be the first step in working out this problem? So Professor Basu, did I miss anything?
No, it is enough.
Bhavna?
Better name-wise you can call.
So only two of you, Sanskar and Shraman, have wrote down two chat messages. Others are still thinking. Bhavna?
Sir, maybe use the mass balance equation.
For what?
Sir, like we need to find the number of trays for that, right?
No, first step. Finding number of stages is a little bit down the line. But how you can get it? Yes. So I think many of you have started to say that trying to draw the equilibrium curve or y versus x curve. So what is this equilibrium curve? What is this y axis or y value and what is this x value? Saksham? Please turn on your video. Saksham? You're not there, right? Please turn on your video and answer to my question.
I don't know.
What do you think? You have studied absorption in mass transfer 1, right? So what do you feel? Come on, it's just sharing thoughts.
I don't know.
Your friends have already told that you want to draw the equilibrium curve y versus x. So what is this y? How do you think you can calculate this y, or what is essentially this y or the x?
Or how did you get X from the data given?
Yes. So you have some data, some values of partial pressure, concentration and all. From there, how do you get your x or y? Anyone else? Ankit Verma? Ankit bhai. Can you turn on your camera, Ankit? So Ankit is not here. Shoaib Nazir. Can you enlighten us? How will you estimate this y? Your friends have already told it's the equilibrium curve, which is correct. So what is this y and x? Shalini? So if you not respond, we will have a note of this. right? Because there is some part of the assessment will go towards your, this class interactions also. Okay, Salini is not here. Rakesh, please turn on your camera. Yes, Ankit, please turn on your camera and respond. I don't want you to raise your hand. I just want to hear what your response. Come on, guys, you have to turn up. This is it's a design class, so we want more discussion rather than one-sided monologue. Palak, Palak, are you there? Sir, তো কেউই কথা বলছে না. Nobody is responding. Hardly very few.
নিধিকে জিজ্ঞেস করো. নিধি.
Yes, sir.
Hello. Can you explain how do you find out XY curve? First you tell about Y data, then X, corresponding X value. Given density of the solution, partial pressures. This data is given in the sheet.
I hope all of you have gone through the problem statement, right?
Everybody should know how to find out equilibrium curve. It is the preliminary part of mass transfer. Rahul Kumayat, are you present? Even it is a problem. They will turn on the PC or laptop, then disappears. অ্যাসাইনমেন্ট ছাড়া কিছু হবে না. Tridipta Das.
Yes, sir.
Hello, you are there. Do you have any idea how to find out equilibrium data?
Henry's law.
Data is given in different form, but you have to convert it into Y and X.
The pressure is given.
You are not audible.
Hello.
Hello.
Yes, sir. Am I audible?
Yes.
Yes, sir. The pressure is given, so we can use Henry's law or Raoult's law
Yes.
and find the equilibrium Y star.
How can you write the expression or something just to be more elaborate? You mean to say this is how you will get the X values, right?
Yes, sir.
So can you tell us or enlighten us more?
All responses will carry marks from the next class. আজকে পড়তে দিয়ে দাও, কালকে next they will take
So I think,
preparation.
guys, it is very important that you have a proper revision of your mass transfer 1 related to the topic on absorption. I think then it would be helpful for you to recap your thoughts and proceed in the same direction. Also, I want everyone to start working on this problem during this week, and next week we can actually have a review on your progress. Right? It's not that you will be working only during the class. You can work anytime and try to coordinate with your group members anytime during the week. And in the class, we will try to clarify doubts, try to understand your progress, try to elaborate things which are of common interest. So these are the purpose of the class, and to engage in lively discussions. Okay, so there is no point in sitting in front of the camera and you work yourself. You can very well coordinate with your group members and work out the problem as per your convenience.
I want to say something. Actually, in offline class, what we do, we give the problem and students do it in the class, and we can watch, we can see student one by one and check it. But in online mode, it is not possible. So by this week, you complete some part of the work, finish it. Then next week, both of us will review it one by one or group wise. And evaluation will be in each week on the basis of performance. Right, Saurabh?
Yes.
So do we have to find the mole ratio from the given data, like PSO2 by total pressure will be the mole fraction, and from there we get the mole ratio of the solute in air, and for that in water we can divide the concentration given by molecular weights, the gram of SO2 by gram of water data.
So partially on the right track. So if you recall, to note or to calculate this mass fraction, there is something small y and capital Y. Now, which one are you referring to?
So I'm referring to capital Y because that is required for the calculation.
What is the advantage of using capital Y, capital X?
So I think it helps in for the numerical calculations. It's just an easier approach.
No, not.
I mean, in the small y or small x, we are representing for a particular component, but in capital, I guess we are representing for the whole.
Both the plots are straight line or curve? With mole fraction basis and mole ratio basis are the same type or different?
So if you plot small x and small y, and if you plot capital X and capital Y, how it will look like? Straight line,
difference?
So mole ratio plots are linear and mole fractions are like curved.
Why mole ratio plots are linear? Any idea, Shoham?
Sir, like when we calculate mole ratios, we are using the liquid and gas in the feed, like the feed. Hello?
Yes, carry on.
Sir, I was saying that while calculating mole ratios, we use the L and G values, which are like the liquid and gas flow rates. And for mole fractions, it's not the same case, I mean.
So what is operating line in this case?
Like the equation of that operating line?
Yes.
Sir, the slope is Ls by Gs, and we have like some intercept. The slope of that operating line is LS by GS.
Is it always LS by GS, or for a particular slope it is LS by GS? It is constant or variable?
So I think for like one equilibrium system, it is, I mean, like for one system, like for example, SO2 and water, I think it should be constant.
So if you vary the feed composition, what will happen?
Yes, sir. If we change the value of feed, then both LS and GS would change. I think so. Then that would change the slope. No, yeah, that would change the slope.
Oh, claro. কে আছে? সৌরভ কি রোল কল করবে এতজনের? সম্ভব না।
না, আমি অ্যাটেন্ডেন্স লিস্ট ডাউনলোড করে নিয়েছি।
ঠিক আছে।
Okay, so I think if there are no more questions, I mean, there is not much that we can discuss right away. And it will be good if you can have a quick revision of your background thoughts, concepts on related to absorption. Then it would be much more fluid and lively. So please go through the problem statement, start working, communicating with your group members, and then we can once again meet next week to discuss more on the progress and your clarifications. So anybody has any questions regarding the problem statement or the group formation?
So I just wanted to know if there is if the problem needs some iterative approach like PED1, or is it a straightforward answer that we'll get?
That you have to slowly find out, Adriya, as you work on the problem. I cannot be a spoiler.
They can use Excel.
You are free to use anything for your calculations, right? Calculator, Excel, MATLAB, Python, whatever is required.
So how much of the assignment do we have to complete by next week then?
As much as you can, right? As much as you can make progress. The faster we do, it will take less number of days to come to bringing it towards the completion. I hope the end objectives are clear. We want to have information regarding the trays, right? Regarding or whether it's a packed column or tray column, that's something you have to define or have to decide. What should be the dimensions of the tower, like height, diameter, and all, right? So at least these are the things that we are looking forward to.
Sir, but it's already given in the problem statement that it consists of Rashig rings packed.
Yeah, so it is a packed tower. Oh, okay, sorry, I missed that then. So it is a packed tower. So you have to come up with this diameter and the height of this column. Find out all the exit conditions. Okay, pressure drops. These are the things that you need to work out. And then slowly we'll talk about the the structural things or the mechanical design. So by next week, if all of you can make a reasonable progress in getting towards the this diameter and height of the column, then I think that is sufficient for 1 week. Okay. Achha, one more announcement. From next week, we are thinking to start this class from 2:30 instead of 2. Is it okay with everyone?
Yes, sir.
Good. I hope it is okay with others also. So if there are no more questions, Professor Basu, I think we can close for today.
Okay. No problem.
Okay then, everyone, thank you. Enjoy the rest of the day, and we will meet again once again in next week at 2:30.